Hello, welcome everyone. We are hosting Postgres Cafe with myself and Sarah. Sarah, can you introduce yourself to us?
And absolutely. I am a Postgres enthusiast of over 12 years. I love Postgres. I work with it every single day and care a lot about the community. So I'm excited to be here with Gulshin working on this Postgres Cafe.
Okay, and my name is Gülçin. I am one of the hosts. I'm working at Xata and working with Postgres for some more than 10 years, 12 years, something like this. I'm happy to be part of the Xata now. I recently joined, and we have Andrew as a guest today for the cafe. And so, Andrew, can you describe yourself a little as well?
Hi, my name's Andrew. I'm an engineer at Xata. I've worked with Postgres for maybe 5 or 6 years. I do various things at Xata, but most notably, I think, I work on schema migration tools. And I think that's what we're going to talk about today.
Exactly. It will be all about schema migration. So, to make it short and very fast, I'm wondering, when I think about schema migrations, what does it come, what's the first thing that comes as pain points when we think about schema migrations? What are the things that for you it's hard topics to solve? What are the pain points that people will face? So we can start with that.
Yeah, I think there are, broadly speaking, kind of 4 main pain points that people have when they do schema migrations in Postgres. I think the first of them we could describe maybe as schema debt, like by analogy to technical debt. So this is where over time engineers, because schema migrations are often sort of slightly scary things to do, people try to do them in the safest way possible, which often means just adding new bits of schema and trying to leave your existing parts of the schema untouched. This minimizes the risks of breaking client applications, but it means that you end up with a very messy database schema building up over time. This has a couple of disadvantages. It's harder for new people to onboard when they're working with the database. And it can also have performance implications if you have things like indices on now redundant parts of the schema that can start to affect the performance of your database as well. So I think that's really just a consequence of schema migrations being often seen as difficult and hard to do. So people try to do them in this kind of additive only way that builds up debt over time.
Right. So instead of doing the change itself, because they can modify something, and so they keep adding more columns, and then it will just increase the size of everything, indexes, walls, to keep everything probably bloated because we are not probably querying stuff. There will be dead tuples. I mean, so many things can go wrong.
Yes, exactly. I think this is something that I've certainly seen in development teams I've worked in over the past, is a kind of reluctance to change existing parts of the schema, just try to add new bits on as far as that's possible.
Right. Okay. So that's schema depth definitely is I like the term as well. The over time it grows on you, and that's definitely a pain. And what others what kind of when I can't think of few, but I wonder what you think is
one of the other big problems I think development teams face with migrations is running into issues with locks. Postgres locks when they're applying migrations to production systems. So it's easy to write migrations that work locally and don't have issues with locks, but then when you try to apply the same migration to a production system where there's actual real traffic, then you can run into problems where most DDL operations take access exclusive locks on the tables they're modifying, and that can lock out readers and writers from the table. So you always need to ensure that when you're doing a DDL operation, you're holding that exclusive lock for as short as possible. And that's the kind of problem that only really occurs in production systems. It's very hard to test for in staging and development environments. So this is, I think, another common problem that many people who've worked with migrations have seen in the past, where you've accidentally lock a table for reads and writes during a migration, and that immediately sort of causes downtime very quickly.
Which is exactly what everyone tries to avoid, right? I always see these questions like, how do I get zero downtime? This magical number of me not having to face this problem at all. How do I do this and not have any problems? So yeah, definitely a common issue, I think.
Yeah, there are quite a few sort of widely known techniques to avoid taking exclusive locks for a long time. Like if you're adding a constraint to a column, you can add the constraint first as a not valid constraint, and then you validate it later. So by splitting into two steps, you reduce the duration that you're holding a lock for. But it's kind of hard to know that you need to do this unless you're like very familiar with Postgres, because it's not something, as I said, you're likely to encounter in a staging or development environment. You just get bitten by it only when you come to do it for real, which is kind of a bad situation to be in.
Yeah, like working as a DBA, like when I was like, it kept my job for long years because like organizing migration is a job itself, right? You have to prepare that this doesn't happen to you when you shut down the website, like what will happen? Like you have to do I need to revert these things somehow? And what if it's in the middle of the migration? Some things are filled, some not filled. Do I have the column? Maybe it's already deleted some columns, and like this whole thing is like really messy. And yeah, nobody wants to be in that state, especially in like some 3 a.m. or something. You have like this problem.
Yeah, you see a lot of organizations that write quite in-depth guides for developers on how to perform schema migrations, like the GitLab migrations guide is a good example.
Yeah.
You end up with these quite complex documents describing how to do these changes.
Yeah, so it also like makes like people's like development cycle so huge, because like to be able to deploy and add something, you'll have to go through a book of changes, make sure everything's work. If in case it doesn't work, how to revert those things, and like what's the impact on the system, and multiple teams probably approvals processes and so on. It's like crazy.
Yeah, you mentioned rollbacks, and I think that's another common problem with migrations is that teams don't tend to, or often they don't even write sort of rollback scripts for the migrations that they apply to production. And if they do, they're often not tested. At least in my experience as an engineer, the need to roll back a schema migration is a kind of incident response level kind of thing. It's not something that people plan for and test for as part of the normal development cycle. I think that's partly because some schema changes are just very hard or impossible to reverse, like dropping a column, but also some data migrations, like they might be hard or impossible to go the other way. And also because schema is very tightly coupled to an application version. So often if you have to revert your schema, you also have to roll back an application deployment at the same time. So having to roll out schema changes and database changes in sync is a big problem that makes rollbacks very difficult.
True, yeah, because like you are actually probably migrating the application, also you are migrating your data at the same time. It's like that's kind of complicated to plan it properly, and it's another layer of complexity on top of everything.
I'm sure it's common too to sometimes find that not everything made it back the way you thought it did. It's sometimes possibly weeks or months later, and then realize, oh wow, that was a huge problem. It's been causing problems this whole time. Awesome.
Yeah, I've certainly worked in a team where we had production incidents caused by schema changes, and then we were unable to revert back to a previous version of an application. The application deployment itself was buggy and needed to be reverted, but we couldn't go back because the schema had changed and the old version of the app was no longer compatible with the schema. So this problem of keeping applications and schemas in sync, I think, is a big problem that teams face.
Yeah, the diversion that happens, and then yeah. Okay, so now that we actually kind of covered, like I think the main pain points and like the how to manage the locking when you have the schema changes, how do you do the rollbacks and reverse things if things go wrong, and not to create the schema debt basically, and how does like pgroll tackle on these issues? Like how do we do better maybe, or in a way that it's useful for people?
Yeah, so I guess the main kind of headline feature of pgroll as a migration tool is that it takes the idea of the expand contract pattern and tries to build that into the tool as a kind of primitive built-in operation. So expand contract is I guess it's a software refactoring pattern, but it's also applied to database schema migrations too. And the idea is that if you want to add some new functionality to your schema, you kind of break that down into multiple steps where you first, let's say, for example, you want to add a new constraint to a particular column. if you wanted to use the expand contract pattern to do this, you would first add a new field to your table and add the constraint to that new field. You would then roll out a new version of your application that does what we sometimes often call a dual write. So the new versions of your app write to both the old and the new versions of the column. Then you can decommission or take out of production the old versions of your application so that nothing is left writing just the old column. At that point, you can do a data migration from the old to the new field. And then you can roll out new versions of your application that just write to that new field. At that point, you can then do the contract phase, remove the old field and rename the new one. So it's a kind of safe way of doing a migration in that it avoids data loss and it keeps both old and new versions of the application able to run side by side. So you don't need to have any application downtime where you just have like a maintenance window where you shut down your application in order to deploy the new version.
Yeah.
I think it's a very powerful pattern for migrations, and it's something that's, I think, quite widely used. A lot of the migration guides that we talked about earlier mention the expand contract pattern. The problem with it, though, is that it's quite hard to do. Like it's involves multiple steps, and it splits the migration between the database layer and the application layer because you have to do the dual writes in the application layer. So you've got to roll out new versions of your app that writes to each schema version. So the idea of pgroll is really that we take the expand contract pattern and we make that a kind of primitive operation in the tool so that you express your migrations declaratively. You say, I want a new constraint on this field, and pgroll will then perform the expansion phase. It will move the dual write into the database layer by using database triggers so that applications don't need to be aware of it. It will present two views, one of the old version of the table, one of the new, so that applications can choose to connect to one version or the other. And in that way, it helps do zero downtime changes because you can keep both the old and the new versions of your application side by side. They just see the version of the database that they expect to see. So I guess, yeah, automated expand contract pattern is maybe one way of describing what pgroll does.
Yeah, because you can actually, in fact, do these things manually, right? Like, but then there is more planning and more probably development involved in it to be able to make the app running with both versions. Yeah. And this way you can just run it like they don't really see this, right? They just like say, okay, I want to add this column and I want to start the pgroll migration, and pgroll does it in the background to doubling with the triggers to have the two versions at the same time, so they can still connect to one thing in their view.
Yeah, it simplifies what the applications need to be aware of in an expand contract migration. The only thing they need to be configured with is know which version of the database schema they need to connect to. So like your database is versioned like it is with any other migration tool. And then when an application wants to connect to either v1 or vnext of the schema, they do that with the search path, Postgres search path setting to control which version they see. But the dual writes are then handled at the database layer, which simplifies things a little bit for application developers.
Yeah, like hugely. It takes out that whole aspect of, oh, I don't know what I'm doing. It takes out that aspect of, oh, like I might know enough of what I'm doing to be able to walk through these steps, but I'm still going to make mistakes along the way, whether intentionally or accidentally, or just because I don't know what I'm looking for. Right? So this automates that automating this process is awesome as a resource to be able to like just get like that's about 90% of the questions I see. Like I said, like getting that zero downtime, figuring out about rollbacks, trying to make that really complex migration process easier to actually accomplish. This seems like that solves that problem.
Yeah, so I think that's really the idea, is to take these sort of complicated multi-step expand contracts that people are doing manually today and try to automate as much of that as possible. And that's really the main idea behind it. I think one of the other benefits we have is that by specifying migrations at a higher level declaratively rather than in raw SQL, we can do some of these tricks we talked about earlier to minimize the duration that exclusive locks are held for. So you just say declaratively, for example, I want a new constraint on my column. And then the tool itself is smart enough to know that it needs to do this in 2 steps to avoid taking that lock for a long time while the constraint is validated against all the records. So yeah, I think the main feature, I guess, is these sort of expand contract migrations get automated. The second one is we're able to be smarter about locking because we don't rely on the migration author knowing all of these tricks and writing them in SQL. We can kind of build that knowledge into the tool.
True. Yeah,
Love that.
Yeah, sorry. And otherwise, like you will have to, like I know, like when I was working as DBA as well, like we have to have the scripts like before migration, during migration, after migration, and in case things go wrong, migration, rollbacks, and like versions. And so, when you were saying that we keep this multiple version at the same time, that will also allow like, okay, I can test my migration for whatever reason, like whatever duration that I feel okay and confident and everything is working, and then I can end the migration. I think that's also possible, right? Like that people can actually decide, okay, I want to really roll back this now, or they can just say, okay, I don't want to, but I want to keep it, let's say, 2 more hours, test everything, and then decide to end. I think that's very, very beneficial for.
Yeah, absolutely. So the idea is that the migrations are kind of split into they're 2-step operations. So you start a migration, and then you have both versions of your schema available and visible to applications, with the tool handling the backfills, the data transformation in the database layer, as we discussed. And you can leave the migration in that kind of expanded state for as long as you want. It could be like seconds or hours or days even. And then at some point, when you're confident that the migration works, the new versions of your applications are working as expected, you can then complete the migration, which does the contract phase. So while the migration's in that expand phase, it's very easy to roll back from because there are no modifications made to any of the old database schema. So rolling back at that point means just removing the parts that only the new versions of your applications depend on, which I think is a big simplification over what it takes to roll back a migration with a kind of raw SQL-based migration tool.
Yeah, I think that's the hardest part also. Like when things roll back, I think is the hardest thing to do, in my opinion. Okay. So I was also like, you also said that like people don't really need to code in SQL for that. Basically, they can just declare like, okay, I want this change to happen, and that's what it is, and they don't really need to code anything in SQL afterwards. Suppose pgroll handle it.
Yeah, that's right. So I think one of the goals we had was that we should be able to specify migrations declaratively as much as possible. Just describe the desired end state of your database schema after the operation, and let the tool work out the details. You still need to write a little bit of SQL for the data migration. So let's say, again, you're adding a constraint to a field. You need to write a data migration that's going to copy the values from the old field to the new in such a way that the constraint is satisfied. So there's a bit of kind of inline SQL, but that's always just kind of data manipulation SQL. There are no DDL statements in the migrations themselves.
Yeah, it's expected. Okay. And how do we use Xata? I mean, we have our own platform for people who are maybe watching new. We are working at Xata, and we have the data platform as well ourselves, and I'm sure that we are utilizing it. So can you explain how do we do it? What do we do with pgroll in production?
Yeah, so we use pgroll in production at Xata. So when a customer performs a schema change on their database, we use pgroll behind the scenes to do that migration. We kind of use it in 2 modes. There's the mode where we immediately start and then complete the migration straight away. So there's never a period where you have 2 versions of your schema available. This is useful when you're just building out your schema. Maybe you don't have any data yet. You're just adding new fields and building out the data model. There, it's not useful at all to have a kind of 2-phase migration. You just want to add a column and have it be there immediately. So that's what we use throughout most of the user interface. But then we also support being able to start an arbitrary migration, leave it in that sort of expanded 2 version phase for as long as you need, and then complete the migration later. So yeah, we're using it in sort of 2 different ways, I would say, in Xata at the moment.
That's useful because like not everybody has to consider everything as a data migration that is visible to them. But if people really want to use it, then they can use the migration view and actually do as we described, keep in as long as they want to test, and then they're confident with the changes to just go with it, complete the migration contract pattern part. Yeah.
So expand contract pattern migrations are useful when you actually care about zero downtime. You have an applications in production, depending on your database schema, but obviously in many use cases that isn't the case. It might be a side project or you're just starting out with something, in which case you want to use it in a kind of simplified way that's more like a sort of traditional migration tool.
Yeah, exactly. Okay. And I was thinking what to discuss more, and I wonder like what's coming next, because I think it's in everyone's mind. Like, so okay, this is the tool currently doing, and what are the plans? Are we developing the tool? What are the features coming? Roadmap.
Yeah, so we have pgroll is still a sort of v0.x project. I think v0.7 is the most recent version. So we're aiming for a v1 release. I would say probably the biggest new feature that we anticipate is I guess we're thinking of it as like integration with other migration tools, specifically ORMs. So right now, if you want to use pgroll, it has to be your migration tool. Like you have to commit to using it in the same way that you would decide that you're going to use, say, Flyway to do all of your migrations. What we see though is that application developers come to Xata with a preferred stack, which includes a migration tool, usually like an ORM, like Prisma, for example. And they don't want to abandon that to use some other migration tool. So what we're kind of planning is some kind of state-based migration inside pgroll as well, so that you can apply your DDL changes with an ORM tool, and then use pgroll to infer what the equivalent zero downtime pgroll migration would have been between that resulting state and the point where you kind of branched off from. So being able to infer migrations between 2 schema states, rather than having a migration author have to write the migration. So I guess I think this is often referred to as like the difference between state-based and change-based migration tools. In state-based, the migration is kind of inferred by the tool by comparing 2 different schemas and then seeing what change is required to go from A to B. And I think that would be useful if we wanted to have pgroll play more nicely with other migration tools, in particular ORMs. So I think that's probably the biggest thing we're planning in the future.
It makes sense what you said, like, the developers already have their own development tooling around, right? They have if they are using an ORM, it's probably unlikely that they will just forego the tool that they are using and switch directly. But making pgroll ORM agnostic in a way that they could be used with different ORMs, it makes sense. And what I wouldn't maybe understand at first, like, okay, if ORMs are doing this, what pgroll add to it? But you also explain it like, because what pgroll comes to the point that to make sure that these are near zero downtime changes. So whatever the ORM change we plan, people just add stuff, I don't know, add constraint and so on, but the tool probably don't safeguard them or protect them against the downtime. And where pgroll comes is like considers these 2 states, like the current state and the state that we want to end up migrating to, and then make sure that these changes that happened in between will be not breaking the system. It will not cause downtime, and we will just manage it for them. And I think that's a big improvement, because that will probably allow more people to use it, and then also make sure that we can actually provide this zero downtime for them for their.
Yeah, I think that's right. The kind of workflow we envisage is like you have a sort of main branch of your database, you make a branch off that and apply some migrations with an ORM tool. And at the point where you're ready to merge that back into main, that's the point at which we could infer a sort of equivalent zero downtime migration with pgroll. And then you would then apply that to your production system as opposed to the ORM generated migration. I think that's the kind of thing we're aiming at.
I see. And also, I think we forgot to mention pgroll is open source. It's not something that is made by Xata only for Xata. We use it in Xata, but pgroll is open source for everybody. And Postgres Cafe will only talk about open source tools. Right, Sarah? We are.
Absolutely. Which actually, I was curious as part of that, what is the contribution policy for pgroll? Like, if I was like, I really want to see this feature, could I just go into the project and contribute? Or would I talk to you guys, file an issue? Like, what does that look like?
Yeah, so it's open source on GitHub. We've already had quite a few external contributors doing just as you say, contributing things that they wanted to see in the tool. We're also part of Hacktoberfest as well, so we had a few contributions arising from that too. But yeah, it's absolutely something that you can just go have a look at and contribute to. Yeah.
Awesome.
I think these are all my questions. Sarah, do you want to have any other question for Andrew?
I think that's it. I think we covered a really nice open source extension. Hopefully others find it just as useful and find it useful enough to comment, start watching the GitHub, take part in discussions on the channel, and try and help it be a more useful tool for everyone. Thank you guys for your work on it.
Thank you. And
thank you.
Thank you, Sarah. Thank you, Andrew. And we'll say bye for everybody now. Until next time. Bye.
Until next time.